Hydraulic fracturing. Hello everyone. Today we will delve into the hydraulic fracturing process commonly known as fracking. Fracking involves the extraction of hydrocarbons from deep underground by creating fractures in the geological formations with low permeability, that are shale generally. These fractures allow the release of trapped natural gas and oil, which can then be collected and used. However, fracking ignites fervent debates about its environmental impact, particularly about water usage and contamination. Tremendous volumes of water are used in the process. Fracking typically requires millions of gallons of water mixed with sand and chemical additives. This water is pumped into deep wells at high pressure, creating the fractures that release hydrocarbons. This raises concerns not only about water usage and availability but also about the potential ecological and environmental impacts. From a water perspective, the main concerns about fracking are: 1. Water use. Fracking operations consume a substantial amount of water, typically ranging from 3 to 6 million gallons per well. This high water demand can strain local water supplies, especially in regions prone to water scarcity or drought. 2. Water contamination. The chemicals used in fracking fluids, along with the release of contaminants from the shale rock, can pose risks to both groundwater and surface water. There is the potential for leaks or spills to contaminate drinking water sources, affecting local communities. 3. Wastewater disposal. Fracking produces a significant amount of wastewater, known as flowback liquid, which contains various pollutants, including radioactive materials, salts, heavy metals, and hydrocarbons. Proper disposal and treatment of this wastewater are critical to prevent environmental damage. 4. Recycling and reuse. Recycling flow-back water is an option, but the process can increase the concentration of contaminants with each reuse. This can make the water more toxic and difficult to manage. 5. Well integrity. The casing and cement surrounding fracking wells are essential for preventing contaminants from leaking into groundwater. Any negligence or well failures can lead to water contamination. In summary, the concerns about fracking from a water perspective primarily revolve around water use, contamination, wastewater disposal, and the potential risks to local water supplies and ecosystems. Another major environmental concern is that fracking can lead to the release of methane, a greenhouse gas, which contributes to climate change. There are concerns about induced seismic activity linked to the disposal of wastewater in deep wells. Main steps taken to protect water during fracking. Well design and construction. Ensure proper well casing and cementing. Well casings are used to isolate the wellbore from surrounding groundwater. A secure casing and cementing system helps prevent the migration of fluids and gases between the well and groundwater. Fluid management. Use specialized fracking fluids. Some fracking fluids are designed to be less harmful to the environment and can include non-toxic or biodegradable components. Minimize water usage. Efforts by the producers are made to reduce water consumption in fracking operations. Flowback and produced water management. Properly manage and dispose of flowback and produced water, which can contain contaminants, including salts and naturally occurring radioactive materials. Norm. Treatment and recycling of flowback and produced water can reduce the need for freshwater resources. Monitoring and testing. Regularly monitor the well and surrounding groundwater for any signs of contamination. Conduct baseline water quality testing before fracking to establish a reference for comparison. Regulatory compliance. Comply with federal, state, and local regulations that are in place to protect water resources during fracking operations. Well integrity and maintenance. Maintain well integrity throughout its life cycle to prevent leaks or failures that could affect groundwater. Implement routine well inspections and maintenance to identify and address issues promptly. Canadian Association of Petroleum Producers recommends best practices for hydraulic fracturing. Under the operating practice, companies are directed to safeguard water quantity through a range of measures, including assessment and measurement of water sources, which includes recycled water. The recommended types of water monitoring include measuring surface water and groundwater quantity data, reporting water use data through CAP's responsible Canadian Energy Program, and ensuring compliance with withdrawal limits and reporting requirements stipulated by water licenses, permits. Furthermore, the practice involves implementing a structured decision-making framework to assess available water sources and promoting collaboration with other companies to adopt best practices. While the specific parameters for water monitoring may vary based on industry best practices and regulations, they typically encompass aspects such as water quality, water quantity, and flowback, produced water recycling rates. These comprehensive measures aim to ensure the sustainability of water sources and address concerns related to responsible water management in hydraulic fracturing operations. The recommendations in the hydraulic fracturing operation practice are aligned with addressing water quantity only, not water quality, and concerns in hydraulic fracturing operations. They emphasize the need for responsible water management, data collection to ensure the sustainability of water resources, adherence to regulatory requirements, and transparency in reporting water usage. These recommendations align with the concerns expressed previously, by monitoring water quantity and complying with withdrawal limits, to minimize the environmental impact on local water resources. Thanks for watching.